Hi, class. This is Mr. G, Mr. Garcia. Now, if you don't have 2.3, make sure you come by and pick it up later, okay? Because since last week, I let you guys know that you do need the new packet. The new packet is 2-3 to 2-4 and 2-5. Okay, so that's what we're going over. So today we're going over 2-3, which are multi-step equations. So that's what we're going to do. We're going to be solving multi-step equations. So yesterday we did one-step equations. All right. So what you're gonna do is you're gonna whatever I do here, you're gonna do on your paper, and then you're also gonna take a picture of it and then submit it. Okay. You're gonna see in the slides where you're supposed to submit it. All right. So here we go. Let's go ahead and start this one. So when you're solving these equations, guys, you gotta actually work backwards. Work backwards right here. Work backwards. And I don't know if you remember, but on an earlier video, or maybe somebody else that maybe it was one of you or two of you, I told you that we were actually gonna use. You remember PEMDAS, right? PEMDAS. That's to evaluate problems. So if you know what the number is and all that, then you go ahead and use PEMDAS. Now, if you're going to solve an equation, like when you were doing the one-step equations yesterday, you're actually going to do this backwards. Okay? I call this Tia PEMDAS, Aunt Sally, Tia PEMDAS. Now, if you do this backwards, it's actually SADMEP. So instead of Tia PEMDAS, it's actually Tio SADMEP. You use this to solve these equations. Okay, now that might not make sense now, but it's going to make sense here in a little bit. So just remember this, write this on your paper. PEMDAS is to solve, like evaluate expressions. SADMEP is actually to solve equations, whether they're one step, two step, multi step, or whatever it is. Okay, and that's what. And if you look at it, it's working backwards from this. See, SADEMEP, SADMEP. So that's what we're doing. So we're working backward is one of the many problem-solving strategies that you can use to solve problems. To work backward, start with the result given at the end of a problem and undo each step to arrive at the beginning number. So you have to start with the result, okay, and undo each step. Undo each step. There's that word again that you saw in the video before this one. Undo each step. So let's go ahead and do example number one. So what I want you to do is take some time to read example number one. Okay, just read it. Don't look at the answer. This is the answer. So read it and pause the video and then come back. All right, so hopefully you did take some time to actually read example number one. So let's dissect it. Let's find out how to solve this, okay? So it says that so let's give it a letter for the number. So let's say this is x. So a number x is divided by 2. So this is a division problem. It's divided by 2, and then 8 is subtracted from the number. So 8 is subtracted from the number. So that means that there's a minus here. Okay? There's a subtraction somewhere going on. Let me zoom in a little bit more. Okay. From the quotient. So the quotient is the answer that you got up here. The result is 16. So the result usually means equals. Okay. What is the number? Okay, so what is x? What is the number x? Let's write it on top better. What is x? So let's see what they did. So you solve the problem by working backwards. So we're going to use Tio SADMEP. Okay, we're going to use Tio SADMEP here shortly. So the final number is 16. Yes? The final number is 16. Undo the subtracting 8 by adding 8. So 16 plus 8 is 24. Okay, and the reason why we're adding instead of subtracting now is because on the original one, they subtracted. So to undo it, you add. Then you undo the dividing by 24 by 2. So you undo it by 2. So now you're going to go ahead and do that. It's backwards. So yeah, you're going to multiply by 24 by 2 to get 48. So the original number is 48. So you actually work backwards to get this. Hopefully that makes sense. If it doesn't make sense, reread it again. Uh, Rewind the video, and maybe it'll make more sense. Now, if you remember from 7th grade, I think Esqueda probably did go over this. Um, I like to go ahead and put symbols on here like this to make a little bit more sense. Okay, I like to do that. So we can actually write an equation from this already. So here we go. So a number x is divided by 2. So x divided by 2. And then 8 is subtracted from the quotient. So you take this quotient, the answer you get, and you subtract 8. The result is 16. So equals 16. There's our equation. So like this or like this. Either way you can do it. You can check your answer. Check. So the answer should be 48, right? So if this is 48, what's 48 divided by 2? 48 divided by 2 is 24, yes? Subtract 8, 16. Mind blown. We're done with example 1. All right, let's go on to example 2. So go ahead and read example 2. Take some time to read it. Pause the video and read it. Just this. All right, you're back. So example 2 talks about bacteria that's everywhere right now, right? They talk about this whole COVID thing. It's just not only bacteria, but viruses are everywhere, right? So in this particular case, a bacteria culture doubles each half hour. So every 30 minutes, this bacteria is doubling, okay? After 3 hours, there are 6,400 bacteria. That's a lot of bacteria after 3 hours. How many bacteria were there to begin with? And Mr. Adamson would probably say, this is probably a little bit of bacteria. It probably should be way, way, way more. But this is just for illustration purposes, okay? How many bacteria were there to begin with? So we know that the bacteria is going to be smaller than 6,400, right? All right, so let's see how they solved it. So we solved the problem by working backwards. So the bacteria have grown for 3 hours. Yes, let's first highlight this. So double means that it was times 2. Okay. Each half hour, so this is 0.5. After 3 hours, there are 6,400 bacteria. How many bacteria were there to begin with? Okay, so the bacteria have grown for 3 hours. Okay, they increased. Since there are 2 1/2 hour periods in 1 hour, so this is 1/2. In 3 hours, there are 6 1/2 hour periods. Since the bacterial culture has grown for 6 time periods, it has doubled 6 times. Undo the doubling by having the number of bacteria 6 times. So here it is. 1, 2, 3, 4, 5, 6, and 6,400 was the original. So you're basically taking half of this 6 times. So half, and you could do it another way. You can actually take a calculator, divide this by 2, divide this by 2, divide this by 2, divide. Once you get that, your answer is going to be 100. So there were 100 bacteria to begin with. Now, this problem, since it involves multiplication and division, this one's a little different when we write an equation. Okay, so we're going to pause on actually writing an equation for this one. I don't want to confuse you guys. For this one was actually a little bit more, the understanding was a little bit better for this one than this one, because this one involves more operations. Okay, so we're not going to write an equation for this one. Okay, but like I said, if you didn't understand it, go ahead and rewind the video or reread the problem again. But basically what we're doing is we're working backwards. We're using TheoSATMap to do it. Okay? All right, let's go on to our next example. All right, so we are on the bottom of page 17 of 2-3 of the front. Okay, so we're going over these problems. Let me see if you guys can see this one. Yeah, there you go. All right, so we're going to solve multi-step equations. To solve equations with more than one operation, often called a multi-step equation, Undo operations by working backwards. So undo operations by working backwards. Reverse the usual order of operations as you work. There's a very important. Reverse the usual order of operations. I'll double underline it. And I'll even highlight it for you guys. Oops. Okay. Reverse the usual order of operations. So you have to use SteelSADMap. SteelSADMap. Okay, I'll put it up here. Oops. SADMap. Pues. SADMap. Which is PEMDAS backwards. That's what we're going to use, okay? Let's go ahead and see how they solve this one. So this one is a multi-step equation. Multi-step because it takes more than one operation to do it. We have on the original one, on the original equation, we have multiplication and addition. So we have multiplication, which is the x, and addition. That's what we have right here. Multiplication and addition. This is an x and this is a plus. Okay, so what do we need to use to undo these, to reverse them? So we're going to need, I'm going to put it in red. We're going to need division and subtraction. Okay, so we're going to undo them. So let's see what SteelSADMap says. So what are we going to do first? Subtract or add? So it looks like right here, they subtracted the 3. There it is. Okay, so they used S. Instead of addition, they used S because it was already being added up here. So now you do the opposite. So 3 minus 3 is 0. 23 minus 3 is 20. So there it is. So we're done with the subtraction. Now we're left with the division now. We're left with the division. So when you divide, you got to divide by 5. So right here is D. So we subtracted. We didn't add. Now we divided. Okay. Divide by 5. 5 divided by 5. 20 divided by 5. X equals 4. And we're done. That's what you're doing, guys. You're using PEMDAS backwards. Okay? That's how you do this one. I'm going to put another problem right here so that we can get a little bit more practice. Okay. All right. So go ahead and copy this one on your paper. Okay. Hopefully you're copying everything that I'm doing up here. That way it makes more sense. Okay. So example, y divided by 3 minus 5 equals 1. Okay. So what type of problem do we have here? So there is division going on here. There's division. And also subtraction. So subtraction and division. Let me write it over here better. So there's division and subtraction. That's what's going on here. Okay, so what do we need to use to undo this? So to undo the division, we're going to need multiplication. And to undo the subtraction, we're going to need addition. Yes? So here's SteelSADMap. So let's go ahead and start solving this one. Okay, so we have, it looks like, do we subtract or add first? It looks like we're going to add first. So we're going to add the 5 to both sides. So add 5. What you do to one side, you do to the other. You have to keep it balanced. Okay, so this becomes 0. So what's 1 plus 5? 6. Now, we bring this down. Y divided by 3. So we already finished the addition. Now we're going to need to use the multiplication. And we're going to do it here. If you forgot, then you also see SteelSADMap up here. We already did the addition. Now we're going to do division. We don't do division because this is already a division problem. But we're going to do multiplication. So we're going to multiply both sides by 3. Y equals 18. Now, let's check our answer. Chécala. Let's substitute 18 back into the y. So 18 divided by 3 minus 5. Now, to solve this, now you use PEMDAS, right? Which is this backwards, right? So you're going to go ahead and divide. 18 divided by 3 is 6. 6 minus 5 is 1. We got the same answer. We're done. I think we forgot to do it for this one. So let's go ahead and do it for this one now that we're here. All right. So we got x equals 4. So let's substitute it back in there. We're checala. So 5. And then x is 4 plus 3. Now when we solve this or when we evaluate this, now we use PEMDAS now. Okay, because we actually know what x is now. So 5 times 4 is 20 plus 3 equals 23. And look, we got the same answer. We're done. All right. Okay, so now just to wrap it up real quickly as far as what we did today. So we're solving these problems by working backwards. So we're using Thiel-SADMEP instead of PEMDAS. Thiel-SADMEP. SADMEP is just PEMDAS backwards. That's all it is. And I like to use Thiel-SADMEP just to remember, you know. Okay, so that's what we did here. We solved for this. I showed you how this was solved. Okay, so now on the back of this paper, you should have these problems. Okay, so let me show you which problems you're going to do. You're not going to do all these problems, okay? So this is the problems that you're going to do. So you're going to go ahead and do number 1. Okay. 5, 6, 8, 11, 15, and 16. And that last one on the bottom, number 24. So go ahead and do these that I just highlighted. Number 1, 5, 6, 8, 11, 15, 16, and 24. Now, the reason why these numbers are all off, guys, is because I cut and pasted other problems off of here. Okay, there's other problems that were in here. There was 3 and 4 that were just too easy. So I cut those out. So that's why you see these weird numbers on here. Okay, now you can go ahead and do the work on here, which hopefully I left enough room. I should have. And then you're going to take a picture of this and submit it in the slides, okay? In the slide that I tell you, okay? If you have any questions, just let me know. Okay, I know today's assignment or the way the layout is, it looks a little different, but hopefully it's maybe a little easier for you guys. All right, guys? Okay, there is no quizzes today, only this. Okay? All right, guys.